Okay, now we are going to look at the first of these two good algebraic methods for solving a system of linear equations, and it's called substitution. And the idea is this. We solve for one of the variables in one of the equations, and then we substitute, hence substitution, this expression into the other equation. And this will give us a single linear equation in one variable, and that is something that is not too difficult to solve. So let's see how this works in the context of the example we just did using graphing. So we are going to solve, and typically when I write down my systems of equations, I actually like to put this little curly bracket here. We have 2x plus y is equal to, this thing is schizophrenic, is equal to 8, and x plus 3y is equal to 9. That's supposed to be an equal sign. That is an equal sign. Alright. So what we did last time is we started with 2x plus y is equal to 8, and we did put this into slope-intercept form, which gave us y is equal to negative 2x plus 8. Okay. But we also solved this second equation for y, and that gave us y is equal to negative x over 3 plus 3. That gave us a fractional slope, and that was kind of annoying. So instead we're going to plug this into the second equation. X plus 3y is equal to 9. We're going to plug this expression in for y, and what we end up with is x plus 3 times y becomes 3 times negative 2x plus 8 is equal to 9. And now we distribute. We get x 3 times negative 2 gives me negative 6x, and 3 times 8 gives me plus 24, and that's equal to 9. We combine like terms. X minus 6 is minus 6x is negative 5x, plus 24 is equal to 9. Now I subtract 24 from both sides, so that I have x alone on one side and all the numbers on the other side, and that leaves me with negative 5x is equal to negative 15, and I divide both sides by negative 5, which gives me, as before, x is equal to 3. So now I've gotten x. Now what we do is we take this value and we put it back into this equation right here. Why? Because this is an equation which tells us what y is in terms of x. So we plug x equal to 3 into y is equal to negative 2x plus 8. And so this is negative 2 times 3 plus 8, which is negative 6 plus 8, and that is 2. And this gives us our solution, which I abbreviate SOL apostrophe n, is 3, 2. Now let me note that I also could have solved for x in this second equation and substituted it into this first equation with just as much ease. The main thing is we want to choose a variable that is easy to substitute for, to solve for, and substitute into the other equation. So let's now look at an example where we solve for x. Let us solve the following system. x plus 3y is equal to 6, and negative 2x plus 4y is equal to negative 2. Now I'm going to choose to solve for x in this first equation because if I were going to solve for y, I would have to divide at some point and I would get x over 3. If I were to solve for y in this equation, I'd have to divide by 4 at some point. I would get, say, negative 2 over 4. That's messy. And if I were to solve for x in this equation, I actually could do it without introducing fractions, but dividing could just be annoying. So let's stick with x in the first equation. So our first step is going to be solve for x in the first equation. We can choose either variable and either equation, but we've strategized and said that solving for x in this equation will be the easiest thing to do. I subtract 3y from both sides, and that leaves me with x is equal to negative 3y plus 6. Alright, now my second step, at this point I'm forced to take x and replace it in the second equation, to substitute it into the second equation. So I really have to plug this into the second equation. With the first step, I have some sort of choice. Which equation do I want to work with? Which variable do I want to work with? But in the second equation, the second step, I'm forced to replace x, the variable I chose, in the second equation, which is the equation I didn't bother with in the first place. So that's negative 2x plus 4y is equal to negative 2. X is equal to negative 3y plus 6 plus 4y is equal to negative 2. I distribute. Negative 2 times negative 3 gives me 6y. Negative 2 times 6 gives me negative 12. Plus 4y is equal to negative 2. I combine like terms and I have that 10y minus 12 is equal to negative 2. I add 12 to both sides, which gives me that 10y is equal to 10. And canceling out 10 on each side gives me that y is equal to 1. Great. Now finally, I'm going to plug y equal to 1 into this equation over here, because this is an equation for x in terms of y. And I just have to plug in y. We often call this back substitution. Let me just write back sub. So we back substitute y equals to 1 into this. So x is equal to minus 3y plus 6, which is minus 3 times 1 plus 6, which is minus 3 plus 6, which is equal to 3. And my solution is, depending on how you would like to write it, you can write it as x is equal to 3, y is equal to 1, or you could write it as the point 3, comma 1. Great. Let's do one more example. Now what happened in these first two examples was that I chose the variable that just appeared by itself with nothing in front of it. Here I had x, and the first example I had two variables that didn't have a coefficient, or the coefficient was 1, x and y. Let's see something slightly different now. This time we are going to solve the equations 7x plus 2y is equal to minus 3, and 2x minus y is equal to negative 4. Well, this time nobody appears as just x or y. The closest thing I have is negative y. The thing is, the coefficient here is negative 1. But that's not going to be that big of a deal. It will still be very easy for us to solve for y in this equation. So that's what we're going to do. So our first step is we're going to solve for y in the second equation. And so we've got 2x minus y is equal to minus 4. I subtract 2x from both sides, and this leaves me with negative y is equal to negative 2x minus 4. Now I want y to be all alone. I've got negative y is equal to negative 2x minus 4. I can get rid of the negative sign on y if I change all of the signs on the other side too. Since both of these guys are negative, I'll just change them to positive 2x plus 4. Great, I've solved for y, and I can plug this into my first equation. Last time we solved for x in the first equation, so we had to replace x in the second equation. This time we solved for y in the second equation, so we've got to replace y in the first equation. So we'll plug this into the first equation, so 7x plus 2y is equal to negative 3. This gives us 7x plus 2 times y is equal to 2x plus 4. So we get 2x plus 4 is equal to negative 3. I distribute, which gives me 7x plus 4x plus 8 is equal to negative 3. I combine like terms. 7x plus 4x is 11x plus 8 is equal to negative 3. Then I subtract 8 from both sides, and this gives me 11x is equal to negative 11. Dividing both sides by 11, the 11's here cancel out, and I'm left with x, and on the right hand side, negative divided by positive is negative, and 11 divided by 11 is 1, so x is equal to negative 1. Finally, I back substitute, and again I will plug x equal to negative 1 into this equation that I have, y is equal to 2x plus 4, because this is just a formula for y strictly in terms of what x is. So y is equal to 2x plus 4, x is equal to negative 1, so I have 2 times negative 1 plus 4. This gives me negative 2 plus 4, which is 2, and so my solution is negative 1, comma 2. Again, notice that it made sense for me to choose to solve for y, because if I solve for x in the second equation, I'd have to divide by 2 at some point, and that will give me a fraction on y. If I solve for x or y in the first equation, I'd have to divide by 7 or 2. That would necessitate me dividing negative 3 by 2 or 7, and I would end up with fractions. Now, a good last thing for us to do here is for us to check our solutions. And let's just do it with this example right here. Solution was supposed to be 2 comma negative 1, and our original equations were 7x plus 2y is equal to negative 3, and 2x minus y is equal to 4. Negative 4, excuse me. So let's just plug these in. Let's call these equations 1 and 2. In equation 1, the question is, does 7 times 2 plus 2 times, excuse me, I got these backwards, x was supposed to be negative 1 and y was supposed to be 2. So the question is 7 times negative 1 plus 2 times 2 equal to negative 3. I'll put a question mark there because I'm not sure. Was negative 7 plus 4 equal to negative 3? The answer to that is yes. Cool. And with the second equation is 2 times negative 1, minus y, which is minus 2, equal to negative 4. Well, 2 times negative 1 is negative 2, minus 2, is that equal to negative 4? Yes. So we have verified that our solution is right. Our solution is right. So you can always check whether your answer is right just by plugging in your solution and seeing if it satisfies the equations.